Here, let's consider how to make the chromatographic peak sharp. Okay? There are two ways, which is um, trapping solute in a narrow band. Okay, so when you inject the solute into the column, yeah, and then the solute must be, the concentrated in a narrow band. Uh, okay, then you will get the sharp, you know, the chromatograms. Okay, so so which means the you trap the solute in a narrow band. There are two ways. First one is solvent trapping. Okay, the initial column temperature is set 40 degrees C below the boiling point of the solvent, mm, which therefore condenses at the beginning of the column. You understand, right? The column temperature is set, this amount of below the boiling point of the solvent, and then uh, the beginning of the the column, the solvent condenses, okay, not vaporized. As the solute catch up with the condensed plug of solvent, and then now solute catches up. Catch up means that it follows, okay, follow and reach, mm, the this condensed solvent. Okay, they are trapped in the solvent. You understand? Now solvent runs faster. Okay, but since the temperature is set below the 40 degrees C, and then it is condensed, solution is condensed, solvent is condensed in the column at the beginning of the column, and then solution now catch up, yeah, and uh, the solutes are trapped in the solvent in a narrow band at the beginning of the column. Without the solvent trapping, the band could not be sharper than the 1 minute injection time. Okay, yeah. Without this solvent trapping, maybe uh, the chromatogram may not be sharper, and the chromatogram may be could not be sharper than 1 minute. Chromatography is initiated by raising the column temperature to vaporize the solvent trapped at the head of the column. Okay, and then now you increase the column temperature to vaporize the this solvent molecules. Okay, another way is to cold trapping. As the name indicates, yeah, the initial column temperature is 150 degrees C lower. Wow, this amount, this is quite low, lower than the boiling point of the solute of interest. Solvent and low boiling components are elected rapidly, okay, but high boiling solute, uh, at any rate, solvent and low boiling components are elected rapidly, but high boiling solutes remain in a narrow band at the beginning of the column. Yeah, these high boiling component solutes are not easily uh, see vaporized, so they are confined in a narrow band at the beginning of the column. The column is then rapidly warmed to initiate chromatography of the high boiling solute, and then now increase the column temperature. Okay, for low boiling solute, cryogenic focusing is required with an initial column temperature below room temperature. But what about the low boiling solute? And then you even lower the temperature, which is called cryogenic focusing. Okay, and then you begin to increase the column temperature. And that way, uh, you can make the chromatograms sharper. Yeah, here is the comparison here for chromatograms for the compound 1 to 3. Okay, definitely this one, this A chromatogram is best one. Okay, this is split injection. Okay, let's look at the read this condition. the solution containing 1 volume percent methyl isobutyl ketone and 1% of paraxylene and in dichloromethane. Okay, the boiling point is 40 degrees C on BP10 moderately polar cyanopropenyl methyl silicon open tubular column. Okay, and column temperature is 75 degrees C. Okay, now this is with the split injection, separation is quite good, and split the bent closed. Yeah, if you close the bent, there's no more bent, so the peak, has a very heavy tailing. Yeah, this is quite not good. Okay? And C chromatogram is the same as the B1, but split bent opened after 30 seconds. Okay, and split bent closed and opened after 30 seconds, and what? And more samples are introduced into the column, right? So this what the peaks are broadened because of the more samples are introduced, and with the solvent trapping, okay, with solvent trapping, you can deal with large amount of your sample. Okay, so this one, and the chromatogram D is quite similar to chromatogram A. Okay, this is a split injection, but this is the solvent trapping. Okay, at the low temperature and increase the column temperature. Okay, so this way solvent trapping is quite effective. And another injection type is on column injection. As I said, this directly you inject your sample into the column used for samples that decompose above their boiling point. Yeah, usually injection port temperature is quite high. Yeah. So if you inject your sample into the injection port, and your solute may be decomposed. Okay, to avoid that case, you can directly inject your sample into the column, right? That's the on column injection. Solution is injected directly to the column. Initial column temperature is low enough to condense the solute in a narrow zone. Okay, so actually you program the column temperature from low to high. Okay, but at the initial temperature, you know, is set at the low temperature to condense the solute in a narrow zone to make this nice chromatogram. Okay. And now let's consider, what kind of detectors are used in gas chromatography. Okay, detectors are so important for qualitative analysis, but our purpose is not qualitative analysis. Actually, people want to do the quantitative analysis. But anyway, for the qualitative analysis, mass spectrometry and FTIR usable by comparison with the spectrum. Okay, with FTIR, for example, by simply finding the functional groups. Okay, the characteristic vibrational band, we know, this compound is there. Yeah? In mass spectrometry, using 2 to 3 prominent peaks selected in little spray ionization spectrum. Okay, qualitative analysis is what you just want to know. Oh, this component is there or not. Okay, and with the mass spectrometry, you try to find out 2 to 3 prominent peak. Yeah, and then you can know if the compound of your interest is there or not. Quantitation ion is used for quantitative analysis. Confirmation ion for qualitative identification. Okay, it should be abundant. Okay, method to identify a peak. So you have to identify the peak. How do you identify uh, this peak correspond to which compound? Okay? There is a way, several ways. Comparing retention time with retention time of authentic sample of the suspected compound. Okay? Only from chromatograms, you have only retention time. Okay, so if you have some kind of pre-knowledge about your solute, and then by comparing the retention time with a standard authentic sample, if retention time matches, and then you may think, oh, this peak corresponds to this compound. Okay, most reliable way to compare retention time is co-chromatography by spiking. You know the spiking. Spiking means that intentionally you inject known compound of a known amount into the column. Okay, which means that authentic compound is added to the unknown. All right. This way, you can, by comparing the retention time, you can know that this peak, separated peaks, uh, is maybe that compound. Okay. So the quantitative analysis, how do we do that? By measuring the chromatographic peak. Okay. The peak area is proportional to the amount of solute. Okay, that is how we do the quantitative analysis. Okay, peak area of Gaussian peak is what 1.064 times peak height times the peak width at half maximum. Okay, yeah. And here this table shows the types of detector and their detection limits and linear range. Mm. Those detectors are used in gas chromatography. Okay, let's look at this one. The thermal conductivity detector and detection limit is not very low. For propane case, is 400 picograms per milliliter. Okay, and the linear range is order of 5, a little bit more than order of 5. And for the flame ionization detector, this is quite a widely used detector, and the detection limit is much lower. Okay, and linear range is much wider. And electron capture detector, this is even the better detection limit down to 5 femtogram per second. Okay, and flame photometric detector. Okay, and the nitrogen phosphorus detector. Those are a very special detector for the specific detection of elements. Okay, and sulfur chemiluminescence detection detector method, it is used for detecting a sulfur compound, and 100 pico the femtogram per let me see, this is second. And photoionization, Fourier transform infrared, and mass spectrometric detector. Yeah, there are many detectors available for gas chromatography. Okay, so let's now study one by one. Okay, let's stop temporarily here.